Sakaro, or Sakaro.io, is a first-person multiplayer game engine built entirely from threejs and TypeScript. With a focus on immersive gameplay, our lightweight but robust and extremely scalable lighting system allow for realistic visuals on low-end hardware such as Chromebooks. Sakaro is planned to be an environment where community content thrives. Our current focus is on the game's editor, which allows for multiple users to edit the same project at the same time. This then leads me to our editor's modular layout, where you can tweak your viewport and drawers to your liking. Our editor also supports scripts which are executed on a web worker. The threejs library isn't being loaded into any of these workers, keeping it light and fast. There's also custom functions to communicate with the editor. You can also undo everything that a specific script has done, like changing colors, positions, with just a click of a button. The UI automatically updates based on what script is changing. There's also an edit mode, where you can tweak individual verts and faces of an object. Although very basic right now, it allows for quick fixes for models and will be improved later in development. This is our minimap generator, where you can tweak individual generated layers such as ambient occlusion or fresnel, creating a desired design. It's also planned to be adapted to weapon icons. Next is the UV generator and viewer. This allows us to generate light map UVs with ease in the editor. We have put a lot of time into our node-based post-processor, allowing us to mix and tweak effects dependent on variables such as the player's health. The goal of this system is to create immersive and responsive effects. It can also be further adapted to tune art styles of the map. For environment lighting, there will be options for dynamics, such as day and night cycles, and static options with baked light maps and environmental probes. For our materials, we are currently using the PBR pipeline. The player controller is a capsule collider being accelerated by a bounding volume hierarchy, also known as a BVH. BVHs are essential as they provide a balance between query efficiency and memory usage. By effectively cutting out parts of the scene that are not relevant to the particular query, BVHs allow for accurate collision detection and many other three-dimensional operations in a complex 3D environment. This in return gives us the budget to render more players and NPCs in an environment without a compromise to performance. We're also moving to a full-body player rig to mitigate common problems with first-person shooters, such as head glitching, where you can see the enemy but your body is completely behind cover. To improve animations for first person and third person, we're going to rely heavily on inverse kinematics, which is slightly functional at the minute. Here is a quick look into some animations in the new player model. For early development, we're going to stick to a robot for the player model. This allows for more customization, such as swapping out different body parts for something such as a armored left leg. Robots also allow for better performance. You can skip out on skinning meshes to the armature and instead make body parts, such as your armored left leg, a child of the armature's bone, and instance the mesh. Here's some early gameplay. Basic NPC AI, navigating with the help of a nav mesh.